So I'm here with Debbie Sturm from the College of Staten Island at the City University of New York. She is an associate professor of computer science. And I have been invited to see a tour of her lab, interview her students, and see the games that she and her students have been making. And I'm really looking forward to it. So can you describe, first of all, your formal training before you came to game-based learning?
Okay, so it was very different. My dissertation was on the three-dimensional modeling of the vestibular ocular reflex. So not at all games, but I see a connection because it was very visual and everything was three-dimensional, and to understand what was going on, I relied on a lot of 3D models. And I feel like what I'm doing now connects with that because it's all about visualizing things and understanding things through visualization. So it wasn't games, but there's like a tenuous connection.
Right away, that's interesting because I think my first project was not on VOR but on eye movements, and so I probably at the same time you might have very been deep into the velocity integrator literature, but for just different.
That's exactly what
that's
doing,
that's
velocity
hilarious.
integrator.
Right. Okay. Interesting. This will probably come to bear in the VR world, right?
Right. You know how people feel nauseous, and I know I do with VR.
Yeah.
So and with space travel, it's all related to the vestibular reflex and to the.
Definitely a canary in the coal mine when it comes to VR, and I think it's also anybody who doesn't do well on boats is probably likely to suffer from that kind of disembarkation syndrome or something. So what got you interested in computer science?
Okay. Really, I took the first course and loved it, and someone recommended that I take, my big sister recommended I take the first course.
Oh, great.
And I loved it from the start, so kept going with it.
Was that in graduate school or?
No, undergraduate. I started undergraduate, and I just kept going with it.
Oh, okay. So what were you? What was the state of the art then for both teaching and learning, and what languages did you have? Were labs set up?
So it's very, very different. I think about this a lot in terms of learning computer science. It's changed a lot over the years because it was a much simpler world. There was much less that you could do, and so everything was simpler. Algorithms were still algorithms, and but we weren't all interconnected, and there wasn't a graphical interface. So even though we were working on terminals, there was one mainframe computer that everyone was connected to. Everyone was using the same language, the same compiler, on the same operating system.
Yeah.
Now, when you're teaching, besides all the graphical IDEs, and each one could be a little bit different, when you're teaching, the students can all be using sort of variations on the different compilers, and so it's more challenging, and there's a lot more going on, a lot more code.
Yeah.
So
we're spoiled
different.
for choice. It's kind of like being in the toothpaste aisle where you have 50 types of toothpaste. And I remember starting in Fortran, and that was, like you said, one compiler, one machine. If on my campus it was one room, period.
So if something went wrong, like you could be like 99% or more sure that it was your fault.
That's an interesting frame of reference because not everybody, and I don't want to single out students, but that's something they have to learn, particularly when they get to graduate school, is that you're probably wrong. In sciences, and the machine is unforgiving about that.
Right. But that's something that's changed because now if something goes wrong, the answer could be, let's say with Unity, the answer could be, oh, do you have the latest Unity? And you could upgrade your software and something could work.
Yeah,
so it makes it murkier.
Yeah, more links in the chain. Yeah.
Yes, much more.
So pardon me, I'm going to break my lap. This keeps on going to sleep, and I hate to. I'm a bad interviewer. All right, here we go. And then I won't have to put my hand on this all the time. Display brightness, auto lock off. Turn this on so I can see it. All righty. Okay, so then what brought you to game-based learning?
That's a very interesting question because I wanted to teach about games. It was very much student-driven. Students were interested in games. I was very interested in recruitment, and I felt that games incorporated everything that we wanted to teach in computer science. So it was software design, it was graphics, it was instant feedback for the students to learn something they were very motivated to do, and AI, lots of AI in there. Almost every subject that you could think of, and then you had to know a lot about the hardware as well. Everything that we were teaching in the curriculum all would come together in a senior level game development course.
Yeah, it's like a jungle gym for computer scientists, right? All the components in
All the
one.
components in one, that you
Yeah.
have to really understand everything to put it together. There's even parallel processing because you have all of the scripts that are running at the same time. Certainly object-oriented programming because all the game objects have their own characteristics. They move at different speeds. They have different characteristics, but they all inherit the same game object functionality.
Yeah.
So there's object-oriented programming, there's, and then there are, of course, data structures where you are collecting data, where you have linked lists of objects. So there's everything in game development. So I was very interested in teaching game development, and it was really just purely to teach it. And we came up with something very innovative on our campus that I haven't seen in too many places, that we introduced a game development course at the 200 level, right after the first course. They have to take the first course, and they could right away take game development. At that level, we also, at a 200 level, we also put a hacking course, and we put a web development course, we added in a robotics course, so we keep putting in, so that instead of students having to wait till they're graduating to learn about all of these nice topics that they're so interested in, we have a 200 level and we have a 400 level.
So I suppose there's two approaches to do this. One would be to break everything up modularly, which is closer to the traditional version, and the other is to infuse every skill in every course, even though they have an emphasis. So you could have robotics, but still teach database methods and encapsulation and OPP. So what, are you consciously picking a strategy, or is it just evolving?
We're trying to give them a flavor of these topics very early on in their careers. We call it early electives, so that then they can specialize and delve into it more. So they're filling in the gaps as they go on. In the 200 level, we have to give them a lot of the code.
Okay, let's scaffold them toward that goal.
Right, and then when they get to the 400 level, they're doing three-dimensional games and more complicated games. But your question was really about game-based learning, right?
Yeah.
And so what happened was that William Bernhardt, Dr. Bernhardt from the English department, was heading up a games and pedagogy faculty interest group. And he emailed me and said, "We'd like you to speak. We know you teach games."
Huh. Okay.
And so I prepared a talk, and I thought, because it's games and pedagogy, I want to also talk about games that are of interest to the audience that'll be there. So I spoke about Foldit, and I spoke about collaborative games where you have crowdsourcing, different experts working on games together.
Yeah.
I spoke about games for learning, and in the audience was Dr. Bertram Plug from the psychology department. And afterwards, he wrote me a long email saying he's very interested in working together, and he wants to write a game for children on the autism spectrum that will assess and possibly remediate issues with emotion recognition. So I started teaching the first game development course in 2008, so we're teaching it a long time here. At the 200 level and the 400 level. And he came to my talk in like 2011, and we've been working together since then.
Yeah, wow.
And from that came a lot of other introductions to people in psychology and neuroscience, and so other collaborations grew out of that.
Yeah.
But it came because I was teaching a regular game development course.
Yeah. Okay.
And then we invited people from the CUNY Games Network to come speak to our group.
So when did you first discover the existence of CUNY Games Network? Was it 2008, 2011?
11, I think.
Yeah, so you've been doing this on your own for a long time.
Yeah, and then
before we
Maura
were-
Smale came
Yeah.
to speak. She was, sorry, I correct that. She was scheduled to speak,
Yeah.
okay, but she couldn't come. And instead, Kathleen came
Yeah.
and Joe. And we had a very nice turnout for that. And it was an eye-opener for me to hear from people who are not in computer science what they are looking for and their needs.
That's what I was actually going to tie in there. That it's funny that all of this started for you as your first contact with somebody else in English. Kathleen Offenholly, Joe Biz, Carlos Hernandez, all these people. Well, Kathleen's from math, but a lot of them came from English. Frank Crocco. So it's odd. At CUNY, at least, it seems like the foundation, the seeds of a lot of this happened in the English department.
English department and and math, and I was able to see it from their point of view, from the domain expert point of view. And a lot of the work that I'm involved in has to do with working with domain experts and designing with them, and also a lot of participatory design. For example, the Connect game that we're working on with psychology, we have students at our college that are on the autism spectrum, and they have been helping us testing the game and also refining the game and designing certain pieces of the game. So we wrote a paper on this that was in a conference on participatory design. Actually, I'm going this summer to present the paper in Vancouver.
Oh, great! Yeah.
An HCI conference.
I'm not familiar. I'm familiar with the notion of design-based research involving the population. Is participatory design a term that's widely used? Is something that you coined? No, it's more.
It's
broad.
used.
Okay. I know.
So from my point of view, as the person who is more on the technical side, I'm learning a lot from working with people from the domain experts, designing a game that they are comfortable with using, and a game that we see how the target audience, how they're playing it. And it's changing. The games evolve. And for me, the biggest education for me is watching people play my games, and now I do that all the time.
Yeah.
Because if you just put a game up in a web player, you don't see people play it. But I go with my laptop and I ask people to play it, and I watch them play it, and I see what's intuitive, what's not. It's not the same as asking them afterwards, was it intuitive?
Yeah.
I see, do they know what to do next?
So you develop a full digital prototype before you bring people in, and you don't do paper prototyping, I imagine.
In the course, we do that a lot.
Okay. Yeah.
We do that a lot, and we do a lot of whiteboard
Yeah.
design.
Sure.
And discussing, and with the Connect game, which has now around 12 levels, the artist, we have an artist, and when he draws something, he sends it around to a very big group, and he gets everyone's feedback to see, is it really, it's supposed to evoke different emotions that the player is going to then select.
Yeah.
So do you feel that this is jealousy? Do you feel that it's complex emotions we're trying to teach?
Yeah, yeah. The reason I asked that question is while we're always taught to prototype and do iterative paper prototypes, that I have heard stories from professional game developers who are so facile with coding that they just don't, because they can do two things at once. They could do some technical testing to see if the game mechanic works at all while they develop this prototype, but it sounds like you're doing both. Maybe.
What we do in the games course, right, in the serious games design course, is that the students have to pitch their game to the class. That's the first thing.
Yeah.
And they have to have a game design document. And they have to show, at some point in the beginning of the course, they have to show certain stills to the class to see and get their feedback.
Yeah.
So the genre of the game and what they're trying to teach and how they're going to assess it. And throughout the course, we get feedback, peer feedback, and so they're developing it with that cycle of peer feedback and changing it. So they're not coding it all up right away, but as soon as they get past the first level of approval from their peers, then they do a very simple game, and then they keep making it better and better and better throughout the course.
When you're in your classroom, so I in my classroom, I do a similar thing, but if you have 30 students in one classroom and you multiply that by 5 minutes, you barely can squeeze that. So how do you do that type of iterative development in a classroom where everybody gets the personal attention they need?
With teams.
So you have more than one, right?
I really feel that students produce more. It multiplies much more than just the 2-3 people. It's more than twice as fast, more than twice as good when they have teams, because they feel responsible, they stay with it, they're inspired by each other. And by getting the peer feedback, by standing up there and presenting again and again and again, they produce better quality projects.
Have you, so the funny story is that in some of these projects, I had a student, as instructors we know there's always social loafing. There's a couple members of the group that might participate. There's always a very strong leader who might bulldoze their peers. And I actually had a student design a game about social loafing this semester, which is funny. So what do you have any evidence of that exists in your classroom? How do you manage it in a design team environment like this?
That is difficult. I've only come across it a little bit. Because they're very motivated.
That's great,
They're very motivated, and it's a very big problem, but because there's usually one student who's willing to put in the work, I usually tell classes, whenever there's teamwork and projects and teams, I always say that I am the project manager. So if you have issues, you report it to the project manager, and then I try to intervene. And it's rare that you can't, and sometimes you have to tell one student, it's true that you're doing more and you're learning more, and sometimes there's no choice if there's one student who falls out, who drops, and it's similar to what happens in the real world. The team dynamic is something that you have to master. And so it's a good skill to master while in college and not later on.
It depends on what area of it you want to emphasize, what student population you have. I have a different population, and sometimes I take a different approach. Not that there's a wrong or right way of doing this, but my approach is that they should learn and experience the struggles of resolving that difficulty, and when they come to me, I give them tools and skills to resolve the problem themselves, and hopefully I'll never be intervened. In fact, I tell them I'm not going to intervene. Usually the thing I tell leaders is that if you have unmotivated students in your team, your role now changes. You are a leader. Your job is now to motivate others, and that's a real world skill. And then suddenly I see a light go in their head because they're partially being rewarded for being good, but then they realize, oh yeah, I'm going to have to whip them into shape. And then I don't hear from them again. So I can only assume things go well. But it's great that you only have to deal with this on a very small scale.
Very rarely.
Yeah, that's great.
I mean, in the last time I taught, there was only one team that finish a complete project.
Yeah. Amazing.
So, are you guys both working on this game together?
Yeah.
Okay, cool. So, why don't you describe a little bit about the game?
So it's a collaborative game where two people are basically put in front of the Kinect, and it's a puzzle they have to put together based on the scene in the background. So if it's a happy scene, they have to put together the emotion for happy and put in the pieces, and they have to do it collaboratively. They can't both take pieces from each other's side. And
okay, who's the target population that this game is designed for?
It's designed for autistic children, or not even children, but people under the spectrum, between ages of I guess college students or kids.
Okay. So and it possibly could be adapted in the future, maybe to younger or older kids if it's effective.
Yeah, if it's effective at helping them recognize emotions.
Okay. who are you partnering with in making the game? Like, who's doing the autism side of this?
The psychology department.
Okay.
The psychology department is doing all the research, and we're providing the software.
Oh, okay. Neat. Great. So it's kind of guided by theories and knowledge experience, and you plug in. Have you had conversations with them, telling them what you think is possible and not possible in this environment?
Yeah, definitely. We meet up every couple of weeks and talk about like what the best way to proceed is for.
Oh, excellent.
Yeah.
So would you say they're involved in the design of the game itself?
Basically, they tell us like what would better like bring out like emotion recognition, like help them recognize emotions, and we try to like adapt to what they suggest.
Wow.
So we both have to like work together and put the pieces into the puzzle.
There are 2 phases for every level, and there are about 12 levels.
Yeah, so right now we're not into the phase where we put in the emotion yet. We're just putting together.
So phase 1 is independent, and you see now.
There's like a short animation that like reveals the second level, and so now, based on the background, there's a happy box. So we have 3 emotions here. We have sad, happy, and angry, and they have to decide which emotion is the person in the game feeling. And so say I picked the wrong emotion from my side, and I put it in, and Hassan puts in the right emotion.
So maybe you want to, Barbara, through that.
The pieces flip back, and we have to try again and see and like work together to collaborate and put in the pieces based on the background. So what do you think it is, Hassan?
There's a present. I'm assuming we'll be happy.
Yeah, seems like it. And there's applause and results come up based on like each person how many puzzle pieces they put in. Okay, so my name is Michael Kladowski, and I started doing game development for Dr. Sturm about last year after being introduced to the course through the game development course at CSI. And there we started with Unity, and I made a linear algebra game to basically help people with math and see how games pretty much help people like learn subjects better than traditional like methods.
My name is Hassan Shubini. I graduated a year and a half ago, and I was interested in this game because of the applicable side of it, and how to use software or games to have an impact on someone that could help improve his daily life. So that's why I stuck with the project.
Yeah.
I volunteer my time from now and then.
Now that you've gotten involved with something that has this application towards a patient population, does that get you? Does it spark or change the course of what you think your career might have been or might be in the future?
Yeah, I think it's really cool, like that we can like change somebody's life like based on like some piece of software that they give them.
Yeah.
So, yeah, I think it's very, very interesting.
For me, yeah, it actually kind of helped me decide what I want to do in graduate school. I'm starting graduate school this fall.
Congrats.
So it's mainly about using data to help in making effective solutions to solve real world problems. So my study will be mainly on machine learning and data science. So it started from there, like seeing actual impacts of your software on actual people that needs everyday improvement.
Yeah.
So far, we haven't had more than 3 students at a time working on a project, and that's very manageable because they can communicate with each other. So smaller groups work for that. And then I'm trying all the time to overlap students so that as students graduate, new students are ready to pick up
So
on
there's
projects.
peer mentoring as part of the
process.
Project. Do you find that when they're part of a small group and do you feel that they get a sense of ownership of the project and they dig in more?
Yes.
Yeah.
These are all funded, so the students are all getting paid too, so that's also an incentive, but I feel like they're putting in more hours than what they're getting paid.
Is there funding through STEM?
They're
or-
different different funding. One is ACM is funding the one with Brooklyn College. The Connect game is a CUNY interdisciplinary research grant, IRG. And then another one is a CUNY, RF CUNY, PSC CUNY grant.
By any means necessary, as opposed to a lot of summer research programs, they get something like an STEM, and then that's just the foundation for what they do. But at this point,
right. So it's 4 different. Another one is a CSI grant. So it's 4 different grants. They all came at the same time. So I have 9 students working, which is like unusual to be working on 4 projects at the same time. It's been very, very busy. This they happened all to come at the same time. Yeah.
Good. All right. So one more you said.
So there's, let me see if I can, is collecting data using Google Analytics. So we are collecting a lot of data. 3 of the projects are IRB approved, and so we can collect data and report on it. And this one has IRB approval. It's called Point Master. Okay, and this one, the original graphics done by one of the students, Claudia Bergudon, and she's a CSI student. And 2 of the other students are at Brooklyn College. And I'm working with Dr. Klotenik, who is a computer science professor. So we're both in computer science. So this is the premise, that rogue robots have taken over the world and dismantled a critical computer, and the player is the mouse, identifies with the mouse, and has to answer questions in order to put the computer back together again. And it's a platform game. We're also, this game also collects data. So we put a it has, again, just-in-time instructions where it gives you information. And then there are these scientists. And this particular game is teaching something called pointers in computer science. And so we did it with graphics, where we try to explain the different concepts. And so you could take your time reading it, and then as you go along, you learn. So there's like a learning phase. Okay, and then there's another level to the game. It's interspersed with learning and assessment. So that's the idea of this one.
Can you explain for those who don't know the difference between, those aren't memory allocation expert, the difference, what a pointer is?
So a pointer is the address of where a value is in memory. And so there's a lot of syntax and a little bit of theory that you have to understand in order to work with pointers, and dynamic allocation, and how to free memory, what happens if memory is freed and you still have a pointer dangling, and memory leakage. These are issues that come up in a lot of programming languages.
Is this a concept you find that's difficult to teach students regularly?
Right. So this is definitely, that's why we chose this. And we're trying to write it in such a way that we could add in other topics as well, but it's not just, and then there's like a little review, and then the next level is the boss level, where you have to battle the boss and answer questions in order to continue. So that's and avoid things, typical platform game type things. Get ready to battle the boss. Okay, and then you're asked questions. And so this game was developed by students in the Serious Games 200 level course. So this is coming in the middle of it, but because it's on the smart board, I could hopefully do this, show you, see the egg cracks open. And then they wrote the game. This is to convert decimal to binary. And over here we have a 1 and a 0. So you can drag and drop the values over, all 1s and 0s. So you can also, that was decimal to binary, but you could also do binary to decimal. Similar idea. They wanted to do something that was sort of cute, but even though it's something that's a college level concept, converting decimal to binary, binary to decimal. Okay, so here's the number 4. And that's the idea of this one, is that I took all of their projects and I put them up using web players and WebGL onto the school server. And as soon as it got onto the school server and students knew that other people were playing it outside of our cozy little classroom, it raised the level of the projects very much. And they each were able to test each other's games on different machines and in different browsers, and we were able to email it out to other people to try it in different locations, and then we got their feedback as well. So here's a completely different game. Each group was able to pick the domain of what it was that they were trying to teach. So this is more of like a Space Invaders type game. They called it Spell Invaders. And here you can sort of customize your game, which is part of what Paul G says, that you should, to be an empowered learner, it's good for you to customize the learning experience. So you could choose the types of ships, and then you can start the game. And here it's teaching homonyms, so allowed versus allowed. And we intersperse teaching and assessment. So teaches something, to difference between allowed and allowed, and then when you start the game, you have to. If you didn't catch that, right? You can touch the. Okay, you can't speak aloud in the library, and then you have to select the right spaceships in order, and each one has a letter on it. This is what they chose to do. So you could. It's a little bit challenging. It's not like an easy game to play, but as you do it, you get scores. If you miss it, then you lose points, and you can power up. Project. And the way that this came about was that a professor in the neuroscience department, Dr. Dan McCloskey, heard about our games and approached me and said that he had an idea for a game that he wanted to use in the classroom to teach neuroscience and psychology students about the brain, about the structure of the brain and also the function of the brain. And he and some of his, I think a graduate student of his name is, I think, Michael Zion, came up with the premise for this game. The premise is that there is a man, maybe a student, who had an accidental autopsy and lost functionality. And the goal of the game is to put his brain back together again. Okay? So, and his name is Will, and the name of the game is Free Will. Okay, so that's the premise. And this is in development. So, it's using game-based learning, and it has 3 scenes. They're not actually separate levels. And the 3 basic scenes are to explore the brain, to learn about it, to a self-assess to see how you're doing. And then the third part is to solve puzzles. And in solving the puzzles, you put together the brain. Okay? The third part is the one that we're working on now. So it starts off by saying, Will thought he had lost his mind. He had, literally, helped free will by reassembling his brain. So that's the premise. We used to have the player felt like you're walking down a corridor, but this is not the final version. Okay, so here we jump into the self-assessment phase, and you're presented with a part of the brain, and here there are just-in-time instructions. This is what Paul G says. You shouldn't get too much information, and as soon as you learn something in the game, that information should go away. So for example, you can rotate arrows to rotate, and if I rotate the brain, so that instruction will go away. So we try to use Paul G's principles in our design. And you could click on the region that matches the name, but let's say for the first one you happen to know it. And so you click on it. If you know it, it animates into place. Okay, so this is all self-assessment. Let's say and we'll do one more, the cerebellum, because it's, let's say you don't know where this next one is, you can choose to skip it. So by hitting S, and if you are stuck, you could also ask for a hint by typing H, and that will color it a different color, and then you can then select it. I'll just do a few of these. It says good job in the middle, tells you when you're halfway done. But let's say you're not sure where something is, so you could also press explore to learn the names. Okay, so you could go to the explore button, and here you're in a different scene, and as you mouse over you see this probe, and it tells you information about the brain, and when you mouse down on it you get more information. Now we also have this animation here, and let's say you're looking at this occipital lobe, and if you want to know about it you can click on it, and the animation will show this young man looking, because this part of the brain helps control eyesight. And it now goes into this third level, and any point you can go to explore to learn more about the brain. Here, if you hit the space bar, you get like a little hint. It says, I feel unsteady and off balance. So you get like a puzzle. Sometimes the puzzles are text-based. Sometimes we're going to put in an animation, let's say, of the man looking unsteady, and sometimes they're auditory. You'll hear him say something about how he feels. And there's also going to be, we're in the process of doing this, there's going to be a off-camera psychologist speaking to him and helping him figure out what functionality he's missing. Okay, so this example was, I feel unsteady and off balance, and this is a morgue. The scene is of a morgue, and you can pan around the room and look for the jars. There's a jar, and the different jars around the room to help complete. Each jar has a brain part in it. So that was, if you remember, it said, I feel unsteady. So that's the cerebellum. So you could pick up the cerebellum, and then you could also continue panning if you want to, and then if you move it to the right place, then you get the next hint.
So you collaborate a lot with designers, and you have two aspects. There's two sides of the coin for game-based learning. One is putting games in the classroom, and the other is having students learn by designing games, and you do a lot of the latter. So is your research in that endeavor grounded in theory, really about pedagogy, about teaching and learning? Because computer science, I don't know what pedagogies they look to when they're saying this is what we're doing for teaching and learning.
So we're using, I like Paul G's principles, 13 principles
Yeah.
of game design.
Yeah, yeah.
And I teach it in my game design course.
Uh-huh.
And they have to show in their game design documents how they're using the different principles.
Oh, this is great. Yeah, yeah.
So
yeah.
empowered learning and co-design, like with the Spell Invaders, they were able to choose their type of spaceship. So the
Mhm.
player, you try to get them more involved. We're trying to add it into our other games as well, where the player can be more involved in the progression of the game.
Yeah.
Also, to get them more immersed in the game, to have a storyline. In our Connect game, the player is supposed to identify with one of the characters,
Yeah.
and there's a whole storyline about how he's being bullied and how he's being left out and
Yeah.
how he then is empowered.
I love that it
It's a
becomes the
storyline.
metaphor, that the motivation becomes the metaphor for the game, the software, the look of the game, things like that. I think web designers have thought like that for a long time. It's great. Let's see, what's this? All right, so how do you, in your classroom, how do you assess learning, both the successes and failures and along the way? You know, the obvious milestone is finishing the game and make it perfect, but
Right.
what else?
Well, we also test it. Part of the courses, they need to test it. And by putting it up in a web player, they're able to send it out to many people to try it.
Oh,
And we
great.
have pre-tests and in-game assessments. So pre-test, let's say with the binary arithmetic.
Yeah.
So it's easy to find people who don't know anything about binary, and you give them a pretest. So they have to also come up with a pretest,
Uh-huh.
and then they play the game,
Yeah.
and then there's a post-test.
Okay.
And they have to write a report at the end showing whether there's been improvement, whether people learned. And they have to have
okay.
learning goals, learning outcomes, and then they have to show how they assessed on those
Yeah.
outcomes.
So your students are effectively learning to become design-based researchers. They're iterating, they're going into the population, they're working with the population to design, and then they're also doing assessment along the way to shape their design.
Trying to do
Yeah.
games that are on college populations so that they can test it on their peers in an informal way.
Readily, yeah, yeah. I imagine you, I think, mentioned off camera or earlier when we were talking that you were working in the autism game, and some of these populations are not readily available. Do you develop using a surrogate population, or do you always work with?
So we test it on typically developing students,
Mhm.
but also we have a population at the college. We have the largest population of students on the spectrum in CUNY.
Oh, I see.
So, and we have a relationship with them. My collaborator, Dr. Gillespie, Kristen Gillespie from psychology, has a whole program for them. And as part of our IRB approval, we also have them testing the game and giving us feedback. So
Excellent.
we are seeing how it works with those students.
Super, super. All right, a couple more. Should understand what people learn. Okay, I think I'll just skip to these last ones. So what do you see about the future of game-based learning, and how can people contact you? There's a lot of other questions, but I think they're broad and you've kind of covered them, like what is innovative about your games, advancing understanding about how people learn in game-based learning environments, promoting broad use and transferability, I think is too much. Right. So what do you see as the future of game-based learning?
I think there are a few obvious things that are coming up. One is VR.
Yeah, exciting.
So that takes a lot of programming, and it's some of the graphics aren't quite there, and some of the hardware has to improve to make everything smoother. A lot of you have to have a lot of material
Right.
to get that going. So VR is an obvious thing. One thing that we're trying to put into our game is some voice recognition.
Mhm.
So our Connect game is trying to promote collaboration between the players. So we want to see, do they look at each other? Do they communicate about
Yeah.
what is the correct emotion to select?
Uh-huh.
And we want to, people communicate in different ways, so we want to also pick up on speech.
Yeah.
So I think VR is one. I think speech is a very big part of the future.
Yeah, it's amazing to see how far natural language processing has come. I mean, when I was a graduate student, it was just a pie in the sky idea, and now it's, look, I mean, obviously it's not here yet, and
Right.
when it arrives, we will have arrived upon the singularity in some ways,
Uh-huh.
right?
Right.
But
And then AI, putting
still.
a lot more AI into game-based learning
Yeah.
so that the experience for the player is customized, because people learn in different ways. Some people want more of a challenge, some people want it to be very low stakes, so it should be very customizable. Some people are more auditory, some people are more visual, so the game should adjust to their different types of players. There shouldn't just be one way to play them. And yeah, AI is very
what
big
about the
part of
future of teaching, since technology is an ever-changing landscape, and schools, universities will always be lagging in the funds and ability and the agility to support these mechanisms? What do you think is the best way to teach these skills? Or what do you think the future of teaching will be like?
Right. So I think you've addressed this in the past too, that it's very challenging to write a game, a digital game, for students to use in a classroom. It takes a very long time, and so it's very challenging, and you might not have the resources to put it together. So I think another thing that the game-based learning development world has to look at is ways to build these games so that they're much more generalizable. And that's something I try to put into my course, so that, let's say, if it's teaching about homonyms, it's not one fixed list. That should be something that is a text asset that's imported and can be applied to other types of games as well. So you should make a game that's not fixed, and it doesn't have one route through it. It's
yeah.
much more generalizable.
Yeah.
And that's so that the domain experts can also direct and can contribute some of the material for the game. So I'm working on that too. So the domain expert is much more involved in the content
Yeah.
and development of the game.
It almost leads towards procedural generation, in that the idea that if you build a structure for learning and practice, that a domain expert could input whatever assets or concepts they need to,
Right.
drag and drop some
Right.
boxes, and have the student play or replay that infinite
So it's not
practice
just
session.
one game, otherwise you're very limited. We have to write games just like we have to write software that in general that is very general and is expandable and changes over time.
Yeah. So developing genres for types of thinking and learning.
And then
Yeah.
you can put in the content.
Yeah, that's great. I mean, I just went to the Cyber Learning Conference, and I went to a panel on computational thinking. Well, computational thinking unfolds for every single discipline, but it's still, numeracy and things like that. So interesting. Okay, last question. First of all, thank you very much. And
you.
how can people contact you if they need to reach you in the future?
Yes, through the CUNY Games Network,
Uh-huh.
great group, or through my email address.
Okay, I'll post that on the screen.
Sturm at csi.cuny.edu.
All right, excellent,
Email works.
excellent. And your key collaborators, you've been collaborating with a lot of people, but maybe the people that are pretty close to home, would you like to mention
Sure.
their
So
information?
Dr. Deborah Sturm is from Brooklyn College. She's in computer science. She and I have a grant from the ACM to work on the games that teach programming concepts.
Okay.
She's one. Dr. McCloskey, he's from the neuroscience psychology department at CSI, working with him on the brain functionality game. And Dr. Kristen Gillespie, and she's doing the autism project with us with a collaborative game for students on the spectrum. And last but not least, Dr. Bertram Plug, who started me off to begin with
Right.
on the emotion recognition game.
How exciting. Cool. Thank you again.
Thank you.